And we'll make that one like that. Same distance. We've taken it out of perspective and run lines like that. And we say, my goodness, those two are parallel. Those two are parallel. Therefore, they must converge at their own vanishing points. And you can then use that to find the hidden divisions. Any questions about this? Yes, Daniel?
If we're using the football field analogy, and we know we have this separated into 10 separate pieces, how do we know where to put the first part?
There's a couple ways. There's 2 or 3 ways. One of the quick divisions you'd make would be what? If you want to divide it in half, so you're dealing with 5 instead of... Right? Yeah, and then you're going to know where the 50-yard line is. It depends on what you are committed to. If you are committed to that, that's the end of the football field. That's the front and that's the back. If you have to have that, then the 2 systems that I show you next week will be better. But if you could move this line, you can kind of eyeball it, or you decide how wide angle is my lens. If you've got a wide angle lens, that first 10-yard line could be right there, right? And if it's that wide angle of a lens, you're going to end up having to exaggerate this business, right? And that way there's going to be more severe reduction. But if you can decide on that first one and then do the diagonal lines and then be able to shift that back line, you'll be safe enough. If you have to get it exact, though, I've given you 3 systems. Next week, I'm going to give you 2 more systems, which are the 2 best systems. They have the fewest limitations. In fact, they really don't have any limitations for measuring things back in space. But in order to give them to you, I have to do 10, 15 minutes of explaining about what the theory is and show you it out of perspective and then do it in perspective. And it should be invigorating and exciting and should take years off your life. I mean, add years to your life. I'm sorry. Yeah. And they're in D'Amelio's book. One of them is to make a special vanishing point, a measuring point, measuring line out of perspective, find a special vanishing point that it will go to, and just make non-perspective divisions and then throw them back to that vanishing point, and they'll hit right at the... It's the simplest and best way. But there's another way, and that is you design your own checkerboard. You design the edge of a checkerboard and then run a diagonal across, and then you can run the lines across, and you'll find exactly where everything fits according to the little plan that you drew. And I know I didn't explain it adequately, but I wasn't trying to. I'm just giving you a preview that there are 2 ways that will solve a lot of these problems next week. But you say, well, why did I give you these 3 if they aren't the best? Because it's nice to have 5 weapons instead of 2. Even if those 2 weapons are the best weapons there are, sometimes it's nice to have a Derringer. Even though a Derringer isn't that accurate, and it only comes in handy at close distances with your opponent. Sometimes that little X fine center thing comes in real handy when you're sketching, and you kind of want to just quickly, okay, oh gosh, it's further back than I thought it was going to be. Also, this gives us a chance to see whether you've understood everything we've set up to this point. Yes?
If you're drawing that football field, like a football field,
there's
fit it in a page.
2 answers to your question. One is, you do this on tracing paper. You do it small on a piece of tracing paper and then blow it up on a copy machine, okay? That is the most logical solution. It's what you tend to fall back on after you've driven yourself nuts by trying to solve... Don't try to solve perspective problems on your big canvas. If you solve them on an 11 by 17 piece of paper about this big and then blow that up on your big canvas, then you can just copy those lines and they'll be close enough. Okay, I know this from experience. That's the first answer to your question. Solve it on tracing paper, small, and then project it. The second answer to your question is that I think that the 5th system next week, the measuring line and special vanishing point, might be the easiest way to do that so you wouldn't have to hassle with the vanishing trace. I mean, I'm working on this piece I'm doing where I've got all of these things in this garage. I've got all these robots and stuff in this garage. I've got some lines on the back wall that are going back in space, and I've got it. It's like doing a crossword puzzle, isn't it? I mean, I've got all these problems. It's like, how will I solve this problem? If I can solve that one, that will help me find that line, and if I can solve that line, it's quite a challenge. And one part of the challenge is determining whether you're going to use your thesaurus, or your dictionary, or ask your friend. And in solving the perspectrum problem, should I use a vanishing trace diagonal? Should I use a special vanishing point and measuring line? For this one, I'm using the vanishing trace diagonal because it's pretty quick. I put a line up here and then I go, and where they disappear because they're going back into the fog. So again, 2 weeks or next week, you'll have 2 more systems, and then you get to have the wisdom of the warrior to know which weapon to pull out of your arsenal. Then you'd have to look for other patterns. Yeah, that's true. Although it would work for a tree line, it works great for tree-lined streets. Any of these systems works fine for tree-lined streets because you only have to find one point, and there's enough variation in tree-lined streets to where you can just go from that point. And again, the most important thing is your composition. This is to help you solve problems. In D'Amelio's book, he's got rows of soldiers in the Civil War. And they diminish. I mean, you could tell it was a big job because there's about 100 soldiers in this picture, and they're in strong foreshortening, but they're all there, and they're there correctly. I mean, they look like they diminish back in space correctly, because he would have gone through and measured out, the basic space they'd fit in, and then eyeball it from there. But yes, all this perspective business is best understood according to man-made things because we are the ones that make right angles. And it applies to circles to some degree to nature. If you look at how the shadow wraps around the moon, as the moon waxes and wanes, it's an elliptical shadow, and it does the tricks that ellipses do. So there's some natural application. But somebody else going to ask something? I see another hand around here. Like always, I will tell you that this is to be learned so that you can then chuck it. But you have to learn it before you chuck it if you want to get any. I found with me, when I'm doing stuff back in space, you can tell if a beginner tries to do this measuring back in space by eyeball, and then you check it, it's way off. But if you do this 6 times, 16 times in the next year, if you measure things out and you kind of, oh gosh, that's a little bit more whatever, you know what happens? You start to then freehand it, and it takes on an authority because you've been down that road and you know what that's like. And you can eyeball it with strength and say, I want it to be this way for my composition, and it's close enough and nobody will ever know. People don't usually take tracing paper and put it over your finished pieces and figure out the perspective. But they will know if you're trying to make it look accurate and you can't. They'll think it looks kind of weird, doesn't it? Anything else?